Hello and welcome back. Paolo is your host tonight. And once more, it is another episode of Conversation Artificial Intelligence. Tonight, we have something very, very interesting, and we're moving to something that you wanted, something that I wanted, and something that everybody talks about. And that's the auto and car industry and the applications of machine learning in the car industry. Now, why is this interesting to you? That's very simple. Car affects everyone else's life. You're gonna learn a lot of things tonight. You're gonna learn where the industry is headed and also how managers make decisions, decide on certain technologies rather than other ones, and what the hiring trends are and what the next technologies will be. If you're new to the channel, it is an honor and privilege to have you here. If you're coming back, thank you so much. So with us today, we have a serial entrepreneur and company executive, Vijay Nadkarni, who not only has started a number of companies, but now is leading the entire artificial intelligence and infotainment section for Visteon, who is a large automotive company. And he is here with us tonight. Hello, Vijay. How are you tonight?
I'm doing well, thank you.
Vijay, you have done so many things. You have started several companies and so on, which would be really difficult to cover all of them. So let me ask you a very provocative questions. I will put in front of you your teenager friends, like when they were 18 years old, they're gonna come here in front of you and they're gonna ask you, what have you been doing? So what are the three things to answer to that?
That's a loaded question, but basically I'm very, very passionate about AI today. In the past, I have worked on several things, and that started out over 25 years back in the wireless industry. I was at Motorola, one of the people responsible for design and architecture of the cellular switch. Then from the mobile industry, I moved into voice over IP at a company called US Robotics, which was later acquired by 3Com. And there I essentially worked on the first generations of voice over IP systems. After Motorola, I started a company called Vijays Networks in voice over IP, which later became a public company. Following that, I did a few additional startups, but most recently, I've been at this company, Visteon. My role, which is an automotive company, we essentially build displays and clusters. That's our bread and butter product line. But what I'm focused on at Visteon, artificial intelligence, largely for autonomous driving and also for infotainment.
You obviously are in a more of engineering R&D position. So
Correct.
You've been a CTO of companies before and so on. People in the industry out there, they look always at Google, autonomous vehicle, a Uber, and they tend in the media, they tend to, attract all the attention. And so you always wait for the next big things coming from these companies. Can you give us a little bit an overview of what else is out there and what are the, trends of applying AI in the auto industries have you identified in the last few years?
Certainly, Google are actually way more, to be more precise. They are, at least for the level 5 system, I'll explain what level 5 means in a second, but they are really more into level 5 fully autonomous architectures and products. What level 5 basically means is that they have vehicles which can drive essentially entirely on their own, really with zero involvement from the driver. And they have a lot of vehicle miles that have been racked up. Other companies that are in this arena are focused more on the near-term applications, which are really what we call level 2 through level 4. A level 2 application is basically one where a limited amount of driver involvement, but by and large, the car will perform basic maneuvers entirely by itself. Things like, for example, adaptive cruise control or lane change maneuver or being able to do automatic emergency braking, what we call level 2 maneuvers. And by using AI, you can actually make the non-AI functions a whole lot better. And that's really what we have been focusing on. This is not the end of, and in level 3, what happens is that we implement functions which can provide real value to the driver. For example, one can do automatic self-parking, for instance, either in a parking garage or in an open parking lot. One can do the highway autopilot, which means that from the entrance ramp of a highway to the exit ramp of that highway, the car will essentially drive entirely by itself, really with no involvement from the driver, except when there is some scenario where the driver needs to take over control. By and large, those are level 3 capabilities, and those are capabilities that we also implement.
So let's, for a second, leave the technical realm and look at the business realm here. If you look at the business, you have companies like Google that trying to develop their software. They buy the cars and they keep, doing R&D with this vision, long-term vision. But if you look at a company like yours, and there are lots of other startups, how does the industry work, basically? You develop the software and the technology for manufacturers? How does it work? Because we also hear that Ford has its autonomous vehicle program. So where does a company like yours fit in the industry?
Sure. So we are what is called a tier 1 automotive supplier. And what that means is that we are basically supply fully manufactured electronic assemblies to the automotive OEMs. And then these OEMs will take our assemblies and then put them into their vehicles. There'll, of course, be a certain period of testing and trial. But once the OEM is comfortable that this electronic assembly works well, then at that point they make a decision about taking it to the market. We essentially implement all the algorithms. We implement the electronics, meaning the circuit boards and designs like that. We also are involved in the initial trials. So we work in general very closely with the OEMs to show them what the product does, to hopefully get them a certain level of comfort in how well it works. Also get feedback from them as to what features they want in the product, because we don't like to develop it in a complete vacuum. We like to we like to make sure that the features really meet the requirements. Once we essentially have an engagement with the OEM, then we will get our requirements typically from a bunch of OEMs, like maybe 5 to 10, and then they will essentially they will comprise the features that we implement, and then hopefully once we've implemented them, we'll get some success with taking them to market.
So what is the actual lifetime of a project here? Like, how long does it take from conception to having the solution in the car driving?
Okay, so the automotive industry is really one where the cycles are on the larger side, typically 3 to 4 years. From the time that we decide to implement, say, a autonomous driving product, to the time where we get the algorithms working, typically takes about 6 to 9 months, thereabout. From that point, along the way, we'll have also engaged with some friendly OEMs and gotten some requirements, but the requirements may also evolve a little further beyond that. Typically, after about a year and a half, we'll actually have a product that works enough to do demos, and it works enough to show it to OEMs. It's not necessarily commercially viable at that point, but it's good enough to take in front of OEMs. And we show it typically to 3 to 10 OEMs. Really depends on how many are interested and want the product. Once we have done that, we will try to form what we call a joint development agreement with 1 or 2 of them. That JDA actually becomes a very important piece of us developing the product, because now what we have is a partnership between us and 1 or hopefully 2 OEMs. We don't want too many of them, but we want at least 1 or 2. With that partnership, they will essentially give us the requirements, and they will work very, very closely, engineer to engineer pretty much. Once we have something that works, they will be there to try it out pretty much right away, instead of us making the whole thing ready and then throwing it across a fence to them. They will be there lockstep with us. That joint development engagement typically itself will last maybe about a year or so. Well, it could last much longer, but to get something that is ready for a trial in some fashion will take, say, about a year. So that is roughly about maybe 2.5 years from the time the project was conceived, the time the trial will actually start. Once the trial starts, then what happens is that they will, of course, try it out. They'll have their own test tracks or whatever it is. They'll have their own set of customers, users, drivers. They will give us feedback. It's a very interactive process at that point, and there'll be many, many iterations, many bugs that are resolved or discovered. We'll fix them. So that cycle basically goes on for maybe another 3 to 5 months. And during that time, we make the product even better. Once the OEM is at the point where they really think this product is good, then at that point, they will typically, if they like what they see, float an RFQ. RFQ is request for quotation, which is basically a fancy term for a bid. And they will invite us, and also the process requires them to invite another three to four parties for that same bid. But since we've been engaged with them, we like to think that we have some sort of advantage over the others. There will be roughly about 5 parties in that bid. It'll go through typically 2 or maybe 3 stages. Typically 2 is very typical. So in the first stage, it'll go from 5 to maybe 2 or maybe 3. And then the last 2 will essentially have a bake-off over some period of time. And there'll be one winner in that bake-off and typically a second source party. So that is essentially how the whole process works. And then, of course, they have the next step beyond that, once you win the bid, is to put it in their vehicles and take it to market.
So for our audience, understand that this process is much more complex than the typical software industry process. Product life cycle is intrinsically different. So new cars are made every 5 years, and new versions of cars comes every year, but they had to be planned several years in advance, typically.
Right.
Second, this is a process where there are lots of players.
Mm-hmm.
So there are various type of OEM, plus there is the car manufacturer involved. Mm-hmm. And there is a lot of levels of risk and so on. So it's a more complex process, and not one where you can deploy an artificial intelligence solutions in production overnight, test it. If it doesn't work, you really go back. Not that large companies do it, like Google likes to do that. They always test. That's really what they're bringing to production. But the speed with which they can do this is way much higher. So we, Vijay, we always hear about autonomous drive, and we hear about cars that drives alone, and we hear about the famous use case that you go somewhere, you forget about the car, and then the car comes back and picks you up, and you do not have to think. But let me ask you this: what else besides autonomous driving is machine learning used for in the car today? Like, what other areas of automation your company or like the industry is pursuing? What else? Like, tell us something different that we haven't read.
And there are 3 distinct elements in infotainment that are important. One is personal assistant, which means effectively something Alexa in the car or Siri in the car, where you can literally talk to the car, maybe just a simple question that needs to go to the internet, like who's the president of the United States, or it could be something about, I saw the engine malfunction right on, tell me more about what's happening. So that, and those are very basic things, but that's what the personal assistant is there for. And the personal assistants are getting more and more sophisticated now. It used to be personal assistants that used to operate mostly at the lexical level originally. The personal assistants are getting to the semantic level, which means they can actually interpret the meaning of the sentences that one asks them. Previously, they used to be just responding to certain phrases, or you had to give very structured information as to what the agent should be doing, the personal assistant agent. So personal assistant is one, and that's an earlier scenario. That's something which I would say is one of the first things in infotainment. There are 2 very exciting areas in infotainment that are now coming into the picture, and I'll tell you about the other 2 areas. So one is driver productivity. What that means is that when a driver is in the car and let's say commuting to work, okay, from home to work. Typically, when they're in the car, and let's say the average commute is about 35 to 40 minutes, that's typical for the US. In that kind of commute, the driver may need to take some appointments. They may have incoming emails. They may have incoming text messages, and they are typically not expected or supposed to fiddle with their cell phones in the car. We do for productivity using AI is we can basically download the calendar invites of the driver. And then from those calendar invites, we can actually pick up the phone number to be called, which could be a regular phone number, it could be a conference bridge, it could be an online URL like a Google Hangout or a Skype URL or something. And then at the time of appointment, the system will give the driver the chance, it will notify the driver and give the driver the chance of placing the call to that party, which could be a conference bridge or an online call. That's the appointment. The other part of it is incoming text messages or incoming emails. And in that, what we do is we essentially capture the sender's name and an ID, and also the content of the text message. If it's an email, we will typically display the first one or two lines, not the whole thing. And that would be displayed either on the head-up display or in the cluster. So these are two things that we do to basically improve the driver's productivity. And this is done using AI. Now, the third area of infotainment that is, I think, hugely interesting, and in fact, I think this will in many ways be a revolution in the industry, is driver profiling, being able to provide recommendations to the driver, which can then potentially lead to monetization. And I'll give you some examples of that. So as the driver drives around, the car basically gets nuggets of information about a driver's activities. Okay, this could be what the driver does inside a car, like what music stations he likes, what artists like to listen to, what kind of climate control settings he likes, etc., etc. So driver does a bunch of things in the car. The second thing is the driver will basically, the car will stop at various locations, points of interest, if you will, and through a reverse GPS lookup, we can find out certain things or certain places that a driver likes to visit. Could be, gas stations, grocery stores, ATMs, fast food restaurants, regular restaurants, schools, whatever it is. All of these basically give the vehicle an insight into the driver's preferences. The third thing, which gets back into driver monitoring, is as the driver drives, there'll be certain emotions that a driver exhibits. So the driver could be basically singing along for a song, or the driver could be, maybe exhibiting frustration in a traffic jam, things like that. All of these are nuggets of information, but the car can correlate the driver's emotions with something else that may be happening at a time. So if a song is playing and the driver has a positive emotion for that, right away a connection is formed that the driver likes this song more than other songs. And then the driver can basically monetize that. This basically leads to the car building up a profile of the driver. And then when the car is in some sort of situation beyond that, like for example, the driver is going from San Francisco to LA, has driven for 3 hours, the fuel is probably running low, and a car knows from its GPS that there is a favorite restaurant approaching in say 5 miles, and maybe a gas station or the driver's favorite brand approaching. The car can make a recommendation to the driver about those two things and let the driver potentially get directions to either or both of those locations.
There are lots of interesting applications. In machine learning, usually one of the use is personalization. So personalization is kind of one of these. So the car basically responding to the person in a personalized way. The other part is the interaction with the rest of the world, the emails and so on. There are lots of questions and directions we could go here, but we would have to be here for like the next 5 hours. So yeah. I think we would make a better service to whoever is watching this. Some of the complexities are involved here. If you look at all the things that you mentioned, these are different areas of machine learning. Also, different type of technologies. So for example, when you talk about the email, displaying the email, there is all the communication display part. When you talk about the personalization, but there is then the recommendation element. So different type of technologies. How do you kind of handle this entire complexity? Is it all in-house? There are several entities that work on this? Something that happens all inside the car, or you have a cloud intelligence somewhere that is computing this thing?
There are fundamentally 4 different AI technologies that we use and let me describe that name for the nomenclature first. So one is CNN, convolutional neural networks, and those are used largely for classification of images and road segments, drivable surfaces. There's a second technology which is called RNN, recurrent neural networks, and there's a specific case of this called LSTM, which is basically long short-term memory. And that's used basically for analyzing or finding patterns in sequences. These could be time-based sequences, temporal sequences, or they could be as regular sequences, doesn't matter. But they are used, for example, for this thing that I mentioned, having to do with extracting phone numbers from calendar invites. We use LSTM for that, or recurrent neural networks. The third area of AI technology that we use is called reinforcement learning. What we use that for is basically discovering patterns or learning patterns by repeated observation. So by performing these activities repeatedly with good and bad outcomes. One can perform certain vehicular maneuvers very precisely, like, for example, adaptive cruise control or lane change or almost any maneuver you can think of, but we have a certain initial set. So reinforcement learning is the third one. And the fourth one is natural language processing, which is basically used for personal assistant. So these are the four, I would say, AI technologies that are used, and we, of course, apply them to these different use cases.
And so all of them are made in-house, so you do not outsource any piece outside.
Well, we do a combination. In general, almost any technology, there'll be a certain, or in general, we will essentially build a certain part of it in-house, and typically a fairly large piece of it in-house. There'll be a certain piece of it that we will partner some, not necessarily always, but in certain cases, and there'll be a certain amount of it, certain percentage, where we may find some open source, or there may be some university projects that we will work with, or have some university partnerships. So it's really a combination of the three.
When we look at the complexity of this ecosystem, I think an important part is where this software is going. Is it going inside the car, or is it going into a cloud solution? Now, for the audience, cloud solution means that we have a central computational building. It's like, one of the Google data centers or another data center where all the computers are, and basically the intelligence is in that center, and the car, it's only kind of a peripheral that sends data and receive orders. That's one model of doing the things. The other model of doing the things is you take the entire intelligence, whatever software, without going into details, you take all of it and you put it in the car, which has other different, requirements. And then there is the hybrid model where you do certain things on the cloud and certain things on the car. So what is the prevailing model right now in the industry, if you can share that?
Absolutely has to be a certain amount of local intelligence in the car. I'll tell you why. Because in a car, you cannot be guaranteed to have internet connectivity at all times. There are two basic problems in the car. One of them is that the internet connectivity, which is typically 4G, at least for now, is not fully reliable. Sometimes, most of the time it'll be there, but sometimes it'll have low speed, sometimes latencies will be too high, sometimes it'll just cut out entirely. So that's number one. The second, wireless connectivity from the car, is you cannot transmit huge volumes of data. You cannot transmit, say, 50 GB of data. And even a smaller amount, like, say, 1 or 2 GB, wireless rates tend to be on the high side. If you need something where you have playing, say, videos in the car or things like that, that will have to come from somebody's data plan. It remains to be seen if the OEMs will offer that or not. There are some trial models out there. Tesla basically has a model where if you pay $100, you get a certain amount of bandwidth, or not bandwidth, but a certain amount of data that they give you for that. These are all things which are evolving at present. But fundamentally, there are these two problems. Because of this, there has to be some local intelligence in the car. And the way it is commonly done is you certainly have a cloud element. You cannot do without a cloud. Cloud is indispensable, because you can have these huge computers and all that. And moreover, what will happen is that from the cloud, from time to time, you can download certain, I would say, smaller models of AI into the car whenever the car is able to, and then use those smaller models in the car for performing whatever local functions it has to.
So for our audience, I hope you appreciate the degree of complexity that we have here. So whereas places like Google might be awesome, and you have a lot of that innovation, and you have lots of R&D and so on, still the level of complexity of taking a solution for Google to the market is much less than the level of complexity of this type of problems where Vijay is working, because in here you have a combination of limitations that go from multiple players in the industry. So it's like you have to rent somebody else's house, you have to rent, it's like to go from one thing to another. Maybe you have to go to the room of somebody else, so you have to ask for permission. That's kind of a industry complexity. The other element is that the accessibility to the internet, it's not there yet for cars, because it's not clear who is going to pay. Remember that in the ordinary internet, in the world of the internet, the retail internet, the people that pay, it's us. We pay the telephone companies a bill every month to get internet. But on the car, that's not yet clear who is going to pay, and the telephone company is not going to give internet gigabytes of
Right.
data transfer for free. I mean, they are there to make a profit.
Correct.
In addition to that, covering cars, it's a little bit more complex because the cars can go, like, for example, take California. We have a huge highway from Los Angeles to San Francisco, but most of it goes into a territory that there are no habitations, so they're very underpopulated. And so it's likely that in that territory, there are not lots of, antenna and transmission systems. But if you now want to cover the car in all the United States, that's probably an infrastructure investment. So somebody has to make that investment. So this is a much more complex solution. Now, for the sake of time, we clearly cannot talk like for several hours because we could go into a lot more of technical details. But would like to, move a little bit towards this. For a lot of managers, they ask themselves the question, how do I bring artificial intelligence into my company? What type of innovation we can do? And I think it would be interesting to know, in a situation like this, it's pretty complex. There are lots of things that come in. How did a company like yours decide to go into autonomous drive? And how are you thinking in terms of what will happen 5 years from now? Because you're going to have products 5 years from now. So what are you going to sell 5 years from now? Can you tell us a little bit about that?
It's a very, very good point. So one point I want to make is that AI is not critical to have in place on day one. There are lots of ways to implement the same thing. Without AI, there are traditional rule-based models, there are heuristic models, which are being used today quite successfully. What AI does is one very, very important thing, which is it basically allows the car to handle exactly one thing very well, which is complexity. So AI, where a car might be able to handle a state machine with, say, 5 states or 8 states, AI can let a car handle a state machine which could be continuous. It could be like 500 states or maybe 200 states. So that's number one. The second thing is it can handle many, many more parameters. A standard model, once you go beyond, say, 4 or 5 or maybe let's say 10 or 15 parameters, even 10 or 15 is a lot, but let's just for the sake of argument, you have 10 parameters. Once you go much beyond that, you get what is called combinatorial explosion, which means that you just get so many scenarios which all have to be coded. You need code for each of these scenarios. And somebody has to, so it's not just the scenarios will code themselves. You have to actually create the state machines for them and then find someone to code them, and that code could have bugs which have to be discovered. So all of that becomes a problem with non-AI solutions. So AI is useful when you need to go to far more complex situations. And my opinion is that before some of these situations, these scenarios go commercial, to make them really perfect, I think AI will be necessary, but it won't be AI all by itself. It will be AI complementing non-AI techniques. So it will be non-AI, AI put together, and then you have something really, really good. So that is, I think, the way it is going to be evolving. But for right now, we start at non-AI, and then we ease into AI as we go. That is basically the way we would do it.
But how does, like, for example, okay, now you lead an entire center here in Santa Clara, and I guess it was not, started when your company Visteon started. So it sounds like something relatively new. How was the decision to build such a center in Santa Clara made? Why? Like, what were the processes that went into, saying we need to go into this direction? We need to have a machine learning division.
So Visteon went through a bit of a transformation in the past. We used to have a lot of additional divisions and BUs in the company. We used to have lighting and interiors and things like that. What we did about 3 years back, spun out some of these other divisions, and we focused on basically one, displays and clusters, and then we added a few more business lines. One was infotainment. The second was centralized domain control. And the third was infotainment. So we've added these two to the original one, which was displays and clusters. But these three, again, autonomous driving, infotainment, centralized domain control, these are new product lines. That is basically the company's makeup. But getting to your question, AI was something which was not done historically in the company. I was brought into the company was essentially to the whole AI initiative. And that is more or less what my charter has been.
So, and if we just for a second, I'm sorry that I dwell on this, but this is really something that a lot of companies are going through. So a lot of companies like Visteon already, they existed. This new technology is coming in, they need to use it. But then one of the question is, how do we profitably use it? How do we, envision the future? So you described a process that's pretty complex on how the product goes to market, and it's just a timeline of 3 years or 4 years. Can you describe how you go one step further? Like, how do you look at the next generation? For example, do you give input to the manufacturer? Do they have something like this? Do you get to influence that process? How do you think basically of the next thing? Not the one thing you're working now that is going to see the light of the day in 3 years, but the one thing that is, let's say, 6 years ahead of time.
There are two parts to that, right? So one is the features or capabilities, and there are the next generation of features and capabilities that will come into the picture in the future. The second is the technologies themselves. So there's a certain set of technologies that are there today, and we use some or many of them. And then there'll be some which will come into the picture a few years out, because technologies also evolve. But in addition to evolving, there are completely new technologies that come into the picture as well. I'll give you an example. One of the technologies that have come into the picture in the last year and a half or 2 years is this thing that I mentioned called reinforcement learning. As a concept has been there for a while. In fact, it was first invented by almost 20 years back, but nothing much happened in that domain for a long time, for almost like 18 years. And then in the last 2 years, it really has taken off, and there are several companies getting into it now. So there are always going to be new technologies coming into the picture. One of the things that I think will happen going forward, this whole notion of the autonomous vehicle being able to handle the last 0.01% of corner cases. This is something that's going to be hugely important, because otherwise what will happen is you'll have scenarios where the autonomous vehicle can handle maybe 99.999% of scenarios. And that still will be absolutely not good enough, because having an accident for every 10,000th car you encounter or every 10,000th traffic light that you overshoot is hugely problematic. There are technologies coming into the picture, and one of them is that of adversarial agents. So adversarial AI, which means you have a good agent and a bad agent who are essentially dueling. So the good agent is basically trying to do something, trying to perform a certain action, and a bad agent is trying to make that action harder and harder for the good agent to accomplish. And both learn from each other, and they essentially, as opposed to having a good agent and having a programmer try to figure out all the scenarios that will essentially pose a problem to the good agent. Here it's the two are learning off each other pretty much. That's one very exciting technology coming into the picture.
So basically, if I understand correctly, here you say there are two big components here. One is the black box. So suppose that we have a black box that has an input and an output, and that's what the manufacturer asks us. So there is innovation that goes inside the black box. Like, we can make this black box better, and that's like something that depends completely on you. And you're saying in this black box, we are likely to move on technologies that will increase the ability of machine learning to take care of variations, especially unexpected variations, because that's where machine learning today still fails. It might fail to a point that is not tolerable for applications like this that are critical, where human lives are at stake. The second part of innovation is, do I have to have 2 inputs? Do I have to have 3 inputs? This is something more complex that usually comes from a variety of discussions and ultimately from the manufacturer. So they decide on that. I find it at the same time interesting, but also challenging, because you have so many constraints that come in, and the freedom of operation is somewhat limited. But that comes now to another area as we go towards the end of this conversation. It's basically, whereas part of these machine learning applications and very exciting applications, they're similar to what happens out there in the software industry. On the other hand, the dynamics of the industry is specific. The technology somewhat is specific, because the distribution of software and computation between the cloud and the peripheral is different than you have it in the software industry. So the question is, when you go and hire people, what are the criteria that you look into? Like, do you want to have experience from the same sector? How somebody that is trying to move from another sector to this could break into this sector?
One thing about AI is that universities in general have started teaching it fairly recently. In other words, although some of the textbooks on this are maybe 15, 20 years old, not very many, but a few. Most universities have not had AI programs, at least not comprehensive AI programs. They may have had the token AI course, but they haven't had serious programs for more than, say, 3, 4, 5 years. It is very hard to find people with lots of experience in AI. So what we do is two things. One is we basically look for younger engineers who may have anywhere from entry level to 4 to 5 years experience, because we find many more of them, and they may not have a huge amount of experience, but they're very good intellectually and they're very sharp. And so we look for people like that. Second is we look for people who may not necessarily have had AI background, but they may have had background in some similar area, like for example, applied mathematics. A lot of AI is heavily math-based, and or somebody who is with a computer science degree. So we try to get people like that, and then we essentially groom them over, say, 3 to 5 months to become quite good at AI. Advantage of that is what we can do is we can basically find people who are inherently very, very good. They may not be good at their domain knowledge yet, but at least as in terms of their intellect and in terms of their inherent capabilities, they're very sharp. And if you have people like that, getting people like that to become good in this domain becomes an easier task than getting people who are maybe not so good, but they may have the domain skills. And later on, over, say, a year or more than a year, they may not necessarily have that intellectual capacity.
So if you are a smart scientist, a smart mathematician, a smart engineer, and you're passionate about these fields, maybe you drop an email to Vijay and maybe you can make it. But otherwise, if you're not passionate, you don't excel to what you do, then it becomes difficult that you can sell yourself in a new industry with new skills. Like you need to have something that is appealing, especially. But right now we are at the point in time where the barrier is not so high. Like people not asking you 10 years of this experience and 30 years of that, because the industry is new. And every time that the industry is new, it's the time where you have a chance to get in. With that said, Vijay, it's a complex, very fascinating area. We could be talking for many, many hours. I want to thank our viewers for being here. If you have questions about this particular interview, please write it down in the comments, and I'll make sure that we'll reach out to Vijay another time, or we'll get this answer for you. And if you want to suggest additional content in this area that we should broadcast into you, just write your comments and subscribe to the channel. For the time being, Vijay, has been an enormous pleasure to have you here. You're doing something very interesting, also very complex. I want to remind this, it's very complex, sometimes more complex than it is working at Google, although many people won't appreciate it, but it is a very complex piece of engineering and R&D here. So Vijay, many thanks, and thank you so much for being here.
Yeah, thank you for having me.